Hello guys, welcome to Whiteboard Machine Learning YouTube channel. In this video, we will see the simple implementation of K nearest neighbor algorithm. To start with, we will import the libraries. I'll import the numerical pi, in short numpy, and I'll import pandas as pd and matplotlib.pyplot for visualization, and I'll also import cborn as SNS. In short, I'll say it as SNS. Cool. Now I'll read the data. I'll say that I'll make use of the pandas pd. Say that pd dot read csv of gene expression dot csv. Okay, that's great. Now you can see that gene expression dot csv, the csv file is having 3000 rows and 3 columns here. The first column is gene 1, gene 2, and then the last column is cancer present. And we have gene 1 and gene 2 as the X features. They're also called as predictors, and we also have the target variable here, which is the cancer present. Alright, now let me try to save this particular file inside a variable called df. Cool, that's great guys. Now what I've done is that I've read the data, which is gene expression.csv. I'm storing that data inside the data frame variable, which is df in this case. Alright, the next step is to inspect my data here. When I say inspect, I'll try to say df dot, I'll try to grab some information about my data set. So for that, I'll start using this information function. When I use the information function, you can see that there are 3 columns here: gene 1, gene 2, and then cancer present or not. And then we have 3000 records here in each columns, and they're basically non-null type. It means that we don't have any missing values in this particular data set, and they all belong to the data type floating point numbers. And we also have the memory usage here, which is 70.4 KB in this case. Cool, that's great guys. So that is basically the information function which is giving us some information about your data set. Now I'll go ahead and I'll say that to get some statistical information, I'll also use something called as df.describe. When I use the df.describe, you see that it is giving me some statistical information here for all the 3 columns. The count is basically the number of records for each column. It is 3000, and then the mean of each column is something like this, and then the standard deviation and the mean, 25th quartile, 50th quartile, 75th quartile, and the maximum value. Okay, so the describe function is normally displaying us or giving us the statistical information about my data. We also try to make use of this statistical information in future, probably to analyze any outliers in my data set. That's great guys. Now coming down, I'll also try to check whether there are any missing values or not. Let's say that I'll say missing values. Okay, how do you check it? Let's say that I'll use df dot is null and then say sum. When I do something like this, you can see that gene 1, gene 2, cancer present are having zeros. It means that there are no missing values in my data set. Okay, now we can make sure that now my data set expression gene expression.csv does not have any missing values. It means that there is no need to handle or impute the missing values in my data set. Alright, now what I'll do, I'll go ahead and I'll check the number of outcomes. For that, what I'll do, I simply say that df of, and I'll take this particular column which is cancer present. I just wanted to check how many number of zeros and ones, something, but the outcomes are there in my data set. I'll say that df of cancer present dot, there's something called as value counts. I'll say that df of cancer present and then value count. When I do this, so you'll be able to see, excuse me, you're getting attribute error. Okay, sorry, it's valid counts. Let's say that it's basically valid counts. Now when I do that, so you will get 1500 zero outcome and 1500 one outcome. It means that we can say that this data set is well balanced data set. Cool. That's great, guys. Now we can also visualize this. I'll try to visualize this using the Seaborn package. What I'll do, I'll say that SNS dot count plot. I'll make use of the count plot, and I'll try to say that count plot basically expects you to pass some of the parameter, and I'll say that it is basically X in this case. You can simply press Shift tab, okay, to get the doc string, and then you'll see that there is something called as X here, and I'll say that X is equal to df dot, and it has to be the cancer present. I'll try to say that cancer present, pass this one, okay, and I'll try to plot the one, excuse me, right. So when I do this, you will be able to see the cancer present in the x-axis, and on the y-axis it is basically the count. You can see that how basically this is visualized using the count plot. Count plot is basically taking the column name here, which is here in this case it is cancer present, and if I when I pass that to my count plot, you can see that the data set are basically balanced. So 0 is nothing but it is the non-canceric, and then 1 is nothing but the canceric. That's great, guys. That is basically how you can perform a simple EDA. Okay, going further, what I'll do, I'll try to also use some other Seaborn functions like pair plot, SNS dot pair plot, just to check the relationship between the different variables in your dataset. And again say that just to save my time, I'll simply say that df of cancer present. I'll copy this and I'll pass it to the df of pair plot. Now what I can do, I can simply say that SNS dot df of pair plot. If you just check the doc string of this, you can see that there is something called as data here. I'll say that data is equal to df in this case. When I say SNS dot pair plot of data is equal to df, and you can certainly see that the different plotting with respect to different pairs of variables. If you just observe this particular graph here, we can see that it is a graph versus cancer present, nothing but your outcome or the target, and then the gene 1. So similarly, cancer present versus gene 2, cancer present versus cancer present. It happens to be the bar plot in this case, right? And then you can also see how basically the graph looks like for gene 2 and then gene 1 in this case. So gene 2 on the y-axis and then gene 1 on the x-axis. So pair plot basically gives us the relationship or the plotting between the different features that we have. Alright, so now what I do, I'll try to also give an option called hue, okay, which is hue. Let's say that I'll try to grab that code, okay, which is hue in this case, right? Hue is equal to, I'll say that it is df of, I'll say it is cancer present. I'll copy this one just to save my time, and then I'll say cancer present. When I do that, you should be able to see the output something like this. Oops, I think we need to pass only the cancer present in this case. That's great. And if I'm going to pass only cancer present, and you'll be able to see the pair plot something like this. Now when I actually pass the u and you're not seeing a y-axis, you're not seeing this cancer present in the y-axis because we are setting that as a hue here. And you can certainly observe here the gene 1 versus gene 1. It is basically the bimodal distributions, and then you can see that the gene 1 versus gene 1, gene 2, right? So it is again a scatter plot overlapped together, and then gene 2 versus gene 1 in this case. And you can also see the cancer present or not, which is basically 0 and 1. Blue indicates it is 0 and orange indicates it is 1. Cool. So that's it for this particular video, guys. So we'll see the continuation of this video, the second part in the subsequent one. Thank you for watching my channel. If you have liked this video, please subscribe to my channel and hit the bell icon. Thank you.